Welcome to hash include and namespaces. That all sounds very technical, doesn't it? So what are we going to be doing in this video? We're going to look at various aspects of code that by the end of it will allow us to do things like hash include IOStream and using namespace standard, and we'll understand what that means and then how that all lets us use character output like this to write out to the console. And when we run our program, we will get simply welcome to bulls and cows. But we'll have learned a lot about what all this stuff means. So let's dive right in and get that working. Okay, so we've got this far. The operating system is calling our code. Now we want our code to do something. So unfortunately, without including some more code, we can't really do anything. We can't print. If we try and type the word print, the autocomplete isn't suggesting anything. You may have seen cout before. That's not here. You'll notice from the first section we did something like this, std, nothing, still nothing. Okay, so what you need to do is understand how we're going to get the code that our code needs in. And we're going to use something called a preprocessor directive. And that is hash. Anything that starts hash is as I say, is a preprocessor directive. There are a few. Hash include is down in this list somewhere here. Hash define, various others, okay? The one we're going to use for now is hash include. Hash include. Now that literally cuts and pastes from another file at the time that you say build. So when you go build or debug, start without debugging, it does a build, and it'll actually literally go to the file that we specify here, which in our case is going to be IOStream, and it will cut and paste the contents above at the top. We don't see it happen, but it's why it's called a preprocessor directive. It happens just before the compilation happens, just before it then goes through all the text, the resulting text, and turns it into a format that the computer can read. So hash include is what we need. Now, when do you use these curly brackets versus when do we go hash include? They're not curly, are they? They're, what do you call them? Chevrons. Let's call them chevrons or angular brackets. You'll also see, if you do searches on the web, this sort of stuff in quotes, hash include. Now, this would be my code.h or something like that, and we'll talk about that later. But the bottom line is that you use these angular brackets or chevrons when you're importing standard stuff that's going to be there because it came with Visual Studio, basically. And when you write your own code and you include your own code, you're going to use the quotes. All right, so hash include IOStream. Now, having done that, Visual Studio now knows about a whole load more stuff. Let's try print now. We actually get a load of methods that include the word print, all of this stuff. We suddenly get a bewildering amount of stuff, actually, which is pretty cool. So the idea of using library code is that other people have written this code. It's been tried and tested over the years, and we know that it's going to work for us. So if we start trying to do things with strings in a little bit, which are a sequence of characters, for instance, we're not reinventing the wheel. We are using somebody else's library code. I talked about in the previous lecture about a library versus an engine. So we're kind of acting like an engine in that the system is calling this main method, and then all of our lines get executed. But then very quickly we're turning the tide and we're saying, actually, we're going to start using libraries. We're going to call out to libraries. All right, so you get the idea, angular braces for the standard stuff. Now what we're going to need to do is to think about how we're going to access our method that we're going to use to print out to the console, which is cout. If I type cout, it doesn't come up. It's not in the list. Cout is for character output, but it's not there. Now the reason it's not there is it's wrapped up in something called a namespace. Now, a namespace does pretty much what it says on the tin. It gives names of things a bit of space. So because when you start importing lots of large libraries, it's quite possible there's more than one thing called print, or more than one thing called cout, or more than one thing called whatever. So it's protected behind something called a namespace. So to get to it, we need to know that it's in the standard namespace. STD is short for standard. When we type STD, this little icon pops up. Now notice that, that's a pair of curly braces, and that is an icon to indicate what type of thing we're looking at in the list. There's various other icons, and they are actually listed in your slides towards the end of this section. There's a summary of what all these icons mean. But STD is a namespace, and in Xcode that's going to be N for namespace. And the way that you access members of the namespace, it's a general way of accessing members here, is : Now we get a list of everything that is in the IOStream library, tagged, if you like, with the standard STD namespace. So I go STD : cout. That's what I need to print stuff out. So let's do the standard thing at this point. And rather than doing hello world, though, I'm going to go welcome to bulls and cows. Okay? And I'm just going to do that. And remember that all of our statements end with a semicolon. And remember that you always need to match your brackets. Now, the system is doing it for you. It's making sure that you've got as many open brackets and closed brackets. And the same thing happens with quotes. We need as many closed quotes as we have open quotes. All right, so that red is a good sign. It means that it's interpreting this thing here as what we call a string of characters all tied together. And let's just try it. So debug, start without debugging. And we have a error. So what's the error? Now, it's an easy thing to do this, is to just try and use cout like this. But actually, cout is a slightly strange beast, and it uses something called an overloaded operator. Now, we'll actually use those and get into those much later in the course. But what we need to do is to use a double back chevron like that. And that double back chevron says, take the value that is here and put it to the character output to the console. Okay? So it's cout, double back chevron, and then your string. Let's try again. I'm just going to go Control F5 this time. Fantastic. Welcome to Bulls and Cows. Press any key to continue. That's ugly. It's ugly that it says press any key to continue straight after Bulls and Cows. So the way that we deal with that, there's at least two ways. One is that we go \n. Now the \/ means that, watch out, there's a special character coming. And the special character is a new line. So \n right in there like that will have the effect of putting any other output onto a new line. And this press any key to continue is coming from the system. Okay, that's cool. Another way of doing this would be to come onto a separate line and type std : cout again, and then put in our \n for new line. That would be another way of doing it. And if we run it, Control F5, we'll see that has the same effect. So another way to do this is to use end line. Now, if we type endl, which you may find with a Google search for end line, it doesn't come up. Why doesn't it come up? Well, it's the same reason cout didn't come up. How do you think we're going to access it? It's hidden in a namespace. Let's try standard endl. Okay, fantastic. So that is, again, hidden in the standard namespace. Let's run, Command F5, and it works. All right, that's cool. One more thing to tell you about cout is that you can string these things together. So instead of keep writing std cout here, I can just delete all this stuff and do that. So I'm just saying, take the result of this and put it onto the end of this, and then put all of that into cout. Okay, let's run it. And it works. Great. Okay, so now I've got a challenge for you. I want you to use something to prevent us from having to keep writing std : every time. We're going to actually use a method called using, and the terminology is using space namespace space and then the name of the namespace, which is standard. So we're going to have using namespace standard, okay? And that is going to go up the top here where I've left space. All right, now doing that is great, and it means that we can avoid having to write this all the time. There is a disadvantage, and the disadvantage is that if two different libraries contain, or even two different namespaces within this library, remember a library like this can have more than one namespace. If two namespaces both contain cout, and we say using namespace standard, if we start doing that a lot, we run the risk of what we call a namespace clash, which is that this method is defined in multiple places and it's not completely obvious which one we're using. So that's the danger of doing it, and I want you to explain that danger to other people in a minute in the discussions the best you can. But here's your challenge. It's a pretty simple one. I want you to make appropriate use of the using statement. I told you the syntax. I've showed you the line you need to put it on. I want you to test by removing the std prefixes from your cout and see if it still works. And you can remove the prefix from the end line. And then explain the risk of using a namespace like this in the discussions best you can. I know that you're brand new to this, and who are you to tell other programmers how to use a namespace and what the risks are, but just have a pop at explaining. If you don't want to do that, don't worry, that's a bonus, explaining the risk. The main thing is that you type using namespace standard and you get rid of those prefixes. Let's go. Cool, welcome back. So let's do that then. Let's watch what happens when we type using namespace, and it's helping us there, std, okay? And then a semicolon on the end. This is a statement. Okay, now if we just run right now, you'll notice that it still runs. No problems, not even any warnings. But what we can do is remove the std from both here and from here. This is making our code a lot more readable. In fact, if you're on a new line, you started typing cout, it's now available here. Okay. So let's go ahead and run. That's it. Welcome to Bulls and Cows. Press any key to continue.
Hi ladies and gentlemen, it's Sam with a post-video edit, and I'm just wanting to say a little bit more about the namespaces being a risk. So it's not a risk to use namespaces in general. It's very good practice, in fact, to use namespaces. It's only a risk if you are using a namespace, because that can cause the clashes. So if you have multiple namespaces used inside one file, then you might end up with the case where cout means different things in the different namespaces and then get a namespace clash. But if you are using the standard : syntax instead, then you should see no problems like this whatsoever.
So as a recap, we've talked about the fact that hash itself represents a preprocessor directive. It tells the compiler to do something before it even starts compiling the code. We've used hash include, which copies and pastes other code into the top of our file, but we don't see it happen. We talked about the idea of using library code. We've used IOStream because it's full of useful stuff for input and output streaming, funnily enough. We've used chevrons or angular braces for standard libraries, and you would use quotes for files you created yourself. We've noticed the namespace icon in the autocomplete with standard there. We've done a few things with cout as well, actually, which I haven't put on this list. And then we've imported the IOStream library, and we've used the std namespace.